Okay, so in this video we're going to be talking about rational expressions. So we're going to be simplifying rational expressions, and then we're going to be multiplying and dividing them by also simplifying. Okay, so rational expressions, a quotient of two polynomials. So polynomial means things with more than one term. Simplest form, the numerator and denominator have no common divisors, which means if you factor it, you've canceled everything possible out. Nothing more can be canceled out of it. That's our simplest form. Okay, so first off we got a factor. So what multiplies to get me 10 adds to get me 7 here. So I got x plus 5, if it wants to write today, and then x plus 2. What multiplies to get me negative 10 adds to get me negative 3. That's x minus 7. X minus 5 I mean. And x plus 2. Okay, so our simplest form, you have to have the exact same things to cancel them, both being positive 2's, both being regular x's. So my most simplified form is going to be x plus 5 over x minus 5. When we're talking about restrictions, which will come up in a couple of problems, restrictions are when I look at step 1 after factoring, what numbers when I plug them in get me 0 in the bottom. So kind of like when we were doing vertical asymptotes and wholes. It's another way to talk about discontinuity. Okay, so my next one here, what multiplies to get me negative 8 adds to get me 2. So I got x plus 4 and x minus 2. What multiplies to get me 6 adds to get me negative 5. It's going to be x minus 3 and x minus 2. So these ones will cancel this time. They're the exact same. So I got x plus 4 over x minus 3. Again, my x's won't cancel because of that plus sign and that minus sign there. Okay, it looks like we have a GCF on the top. Remember, factoring, we can always take GCFs out. So I'm going to go ahead and take a 4 out because it looks like they both share it. So realize that you can take a GCF of a number. You can also take a GCF of a letter or a negative number. So this would get me 3 minus x. My bottom, remember this, if I wanted to rewrite it, it's missing that 0x in there. So what multiplies to get me negative 9 adds to get me 0. And that is going to be x minus 3 and x plus 3. Okay, this looks very similar to what one of the other ones is. So if I wanted to rewrite it, I want to flip-flop my x and my 3. So when I flip-flop it, I need to make sure that negative stays with the x because that's where it's attached to, and then it's a positive 3. Okay, and then it's still not exactly like what I want it because of that negative x. So what I can actually do is take out a GCF of negative 1. So if I divide both of these by negative 1, we're going to act like they both have them in common. So now when I pull it out, it becomes negative 4 on the outside. Negative x divided by negative 1 is a positive x. 3 divided by negative 1 is now a minus 3. So you can take a GCF out of a negative number. I could have taken negative 4 out in the first round there. And now you can see that they match. So these ones will cancel. All I have left on top is negative 4, and then on bottom I have x plus 3. So some of these you can kind of manipulate to get them to be the same. So you got to be wary of how far you go. So if I'm doing the top here, what multiplies to get, I'm just going to factor all of it and then see what simplifies. Because if I'm multiplying, technically it's like this is a big, long fraction here. So that's what we're going to act like it is once we factor it. So what multiplies to get me negative 6 adds to get me 1. And that is going to be positive 3 and negative 2. I can't do anything to the bottom, so we're going to leave him like this. The top, remember, it's missing the 0x, so what multiplies to give me negative 25 adds to get me 0. That's going to be negative 5 and positive 5. And then the bottom, what multiplies to get me 3 adds to get me 4 is going to be x plus 3 and x plus 1. So if I think about this as a very long fraction bar with all of them being multiplied, okay, because multiplying, we're not flipping anything, we're just combining them. I can see what things I can cancel based on making a big fraction. So I look like I have x plus 3 on top and bottom. I also have x minus 5s on top and bottom, and that looks like everything I can cancel. So I have an x minus 2 and an x plus 5 left on top, and then an x plus 1 left on bottom. Okay, restrictions, we go back to our completely factored, and we count all of the things that we don't want x to equal. So x we don't want to equal a positive 5, because if I put a positive 5 in there, it gets me 0. I also don't want x to equal right here a negative 3, because it gets me 0. And I also don't want x to equal a negative 1. Okay, so it's a little different. Normally we say, for asymptotes, we say x equals. In these situations, we're restricting them, so we don't want x to be those certain things, because we're not talking about asymptotes. We're just saying, hey, what do we don't want these x's to equal to get zeros in the bottom? We're not technically graphing them, so we don't really care that they're asymptotes or wholes. Okay, so it looks like we got a GCF on top here of 2. So it will become x minus 4. Remember, you divide it out and put the 2 in front of the parentheses. What multiplies to get me negative 16 adds to get me 0. That's going to be a negative 4 and a positive 4. What multiplies to get me 4 adds to get me 5. A plus 4 and a plus 1. What multiplies to get me 16 adds to get me 8. That is going to be a positive 4 and a positive 4. So we're going to pretend like it's a big fraction bar again, and I'm going to start canceling. So I can only cancel one of them on the bottom because it only matches with one of them on the top. And remember, the only time they cancel is top and bottom. So I cannot cancel these because they're both on the bottom. It's like having x over x. They cancel. If I have 2 x's on bottom, it becomes x squared. So same on the top and the bottom. It looks like we also can cancel those ones here. So I have 2 and then x plus 1 left on top, and x plus 4, x plus 4. If we wanted to rewrite that, we could write it x plus 4 squared. Restrictions, we look back at this one here. So I don't want x to equal a positive 4, because 4 minus 4 gets me 0. I also don't want it to equal a negative 4. Negative 4, negative 4. So only those two would be bad if I plugged it in, because I'd get 0 on the bottom. Okay, we got a division sign. So let's go ahead. Whenever I divide something, it's also the same as multiplying by its reciprocal. So what I'm actually going to do is rewrite it with my left side the same, but multiply by the reciprocal. Reciprocal means you flip it. So we're going to go ahead and flip that. So I got x squared minus 1 now on top, and x squared plus 3x minus 10 on bottom to make my life easier, so it switches to a multiplication. Division is the same as multiplying by the reciprocal. If you're dividing by 2, so let's say I have 3x over 7 divided by 2, that's the same as 2 over 1. Okay, that's the same as if we're dividing something by 2, we're cutting it in half. So 3x over 7 times 1/2. Multiply by the reciprocal. Same thing. Okay, so now we have to go ahead and do our factoring. So it multiplies to get me 1, adds to get me 2 here. It is going to be x plus 1, x plus 1. What multiplies to get me negative 1 adds to get me a 0, so x minus 1, x plus 1. What multiplies to get me negative 10 adds to get me 3, x plus 5, and x minus 2. So let's go ahead and see the simple things to cancel. It looks like I can cancel these x plus 1s. So then it becomes 2 minus x, and we still have x minus 1 on top. We still have this x plus 1, this x plus 5, and this x minus 2. Okay, anytime you see this x flip-flopped, go ahead and flip it so the x is in the front. So now it's going to be negative x plus 2. Remember, the negative stays with it. X minus 1, x plus 1, x plus 5, and x minus 2. Okay, and then this is going to be similar to the last one. I can actually get this negative x plus 2. If I take out a negative, it's going to flip the signs, and then I'll have more things canceling. So I'm going to divide a negative out of just this one here. Okay, I don't have to do it out of both things on the top. So if I take out a negative 1, it's going to become x minus 2. x minus 1 over x plus 1, x plus 5, and x minus 2, because it flips all the signs in here when I take out a negative. And now I can actually cancel those x minus 2's. So anytime there's an x on the back end, go ahead and flip it, and then check to see if taking out a negative is going to cancel anything. So now all I have left is negative 1 times x minus 1, and then I got x plus 1 on bottom, and x plus 5. Okay, so there's nothing else that can cancel, so that's going to go ahead and be my answer. My restrictions, I go back up to the part that I've already flipped. I can't have x equal to negative 1, negative 5, and positive 2, because we're just looking at the bottoms. Okay, so we do the same thing. So I got x squared plus 5x plus 4 over x squared plus x minus 12. We multiply by the reciprocal, so I have now 2x squared minus 6x on top over x squared minus 1. We are going to go ahead and factor. So the top one, what multiplies to get me 4, adds to get me 5, which is going to be 4 and 1. The bottom, what multiplies to get me negative 12, adds to get me 1. That's going to be positive 4 and negative 3. This top here, it doesn't look like I can factor, but there is a GCF. They both have a 2 in common, and they also both have an x in common, so I'm going to take out a 2x. 2x squared divided by 2x is going to give me x. Negative 6x divided by 2x gets me negative 3. Go ahead and factor the bottom, so what multiplies to get me negative 1 adds to get me 0 is going to be negative 1 and positive 1. And let's go ahead and do some canceling. I have an x plus 1 on top. My x minus 3's here cancel. And my x plus 4's top and bottom cancel. So I have 2x over x minus 1. My x's do not cancel because of this minus sign here. My restrictions, I go back to this set right here. I don't want x to equal negative 4, 3, 1, and negative 1. So just the values that when I plug them in for x here get me 0. Okay, this is the exact same thing as our regular division sign. So if I wanted to rewrite it to make it look like how it looked in the last one, I would just say divided by n minus 7 over n plus 1. It's just a different way to look at it. We're still going to have to do the flipping of it to get it to be multiplication. So it's going to be n plus 1 over n minus 7, and then we go our factoring route. It's just a different way to see a division sign. So it looks like we're only factoring this one here. So what multiplies to get me negative 8 adds to get me negative 7. So I'm going to write it over here. So I have n minus 6 on top. That is going to be negative 8 and a positive 1 times n plus 1 over n minus 7. So our n plus 1's cancel. I have n minus 6 over n minus 8 times n minus 7. My restrictions this time, so I go back to the ones before I started canceling. I don't want n to equal 8, negative 1, or positive 7. Okay, so we're multiplying, so all we need to do is factor. So this one's already factored, both top and bottom. So now I'm just going to look at this set. So it multiplies to get me 4, adds to get me negative 4. And it is going to be negative 2 and negative 2. The bottom has a GCF of c, so I'm going to take a c out. C squared divided by c. If I take a c out of c squared, I get c left. If I take a c out of 6c, I have 6 left. So I can cancel one set of those. So then if I wanted to rewrite it, I have c squared times c minus 2 over c times c minus 6. I can actually simplify these because they're being multiplied. So if I have 2 c's on top, 1 c on bottom, they actually cancel the set on bottom here. So I'll have a c on top left. Or you could do, when you divide things with the same exponent, with the same base, you subtract the exponent. So 2 minus 1 gets me 1 c left on top. So that is my final simplify. My restrictions are a little weird this time. So I go back to this before I started canceling. I don't want it to equal 2 or 6. I also don't want it to equal 0. right here. Because if I plug a 0 in for that C right here, I'm automatically going to get a 0 in the bottom, because anything times 0 is 0. So anytime it's just the letter, you're going to have it to be represented by 0 in this situation.